Hello everyone, welcome to Physics Plus. In this video we will learn about the conservation laws in classical mechanics. So in the conservation laws there are different subparts such as conservation of linear momentum, conservation of angular momentum, etc. So we'll start with conservation laws. In here we will learn about conservation of linear momentum. Now we know that linear momentum is represented by P, right? So assume that you have a force F, and if a force F is acting on a particle of mass m, then according to Newton's second law of motion, we can write that F is equal to dp by dt, or we can write d by dt mv, right, where p is equal to mv, which is the linear momentum of the particle. So we can write that this is equal to p, right? So p is equal to mv, which is the linear momentum of the particle. Now if the external force is 0, so if this is 0, then we can write that d by dt mv is equal to 0. That means that mv equal to constant, or we can say that p equal to constant, right? So what is one example that we can see in this case? So assume that we have two particles. Let's say we have one free particle here and another free particle here, and assume that both are moving towards each other, right? So, and assume there is no external force. So what will happen is that it will move towards each other. It will have an elastic collision. Assuming that they don't lose energy, then the final linear momentum of the system and the initial linear momentum of the system will be same. We can see that from the animation as well. So this is the conservation of linear momentum. So basically what it means is that the linear momentum is conserved. By conserved, it means that the linear momentum is constant when an external force is not acting on the system or on the particle. Okay, so yeah, that's it. Thank you for watching, and subscribe to our channel for more quality videos. Thank you.